By far the most important concept in kinematics is acceleration. It's a measure of the change in velocity over time, and that's what we're going to discuss it today. Next, the way we define mathematically acceleration, and in fact average acceleration, is by the equation that you see on the left side, which is the difference between the final velocity minus the initial velocity over the time interval. For simplicity, let's choose 2 points in the trajectory shown on the right side. An object is thrown up, and say at a certain initial point the velocity is 15 meters per second. Later on, at 1 second, say the velocity is 5 meters per second. If we do a simple calculation, look at the equation on the left, it says A up. You take the final velocity, which is 5, minus the initial velocity, which is 15, divided by 1, it will give you negative 10 meters per second squared. Now, on its way down, say at a certain point, the velocity is negative 5 meters per second. The negative indicates direction. Then, 1 second later, the velocity is negative 15 meters per second. If we again do the calculation, you see that on the left side, the acceleration down is final velocity is negative 15 minus negative 5 divided by 1 second, again is negative 10 meters per second, which indicates that having a negative acceleration does not mean that the object is slowing down, nor necessarily speeding up. It depends on the signs of the velocity. So again, the acceleration is a measure of the change in velocity. That's what it is. We have made the numbers a little bit simpler so that we can do the calculation in our heads, but the actual value at sea level is that we see right there indicated. The acceleration due to gravity alone is negative 9.8 meters per second squared. We end our discussion at this point.